Dear students, today let us study about elasticity. In general, we know in some materials when an external force is applied, the dimension, shape and length of the materials will be changed. That means it will be increased. But when the external force is removed, the materials will regain its original shape and size. We all know this property is nothing but the elastic property. This is a peculiar property for some materials. We very much familiar about the elastic body such as rubber and also the metal wire. When we apply the load, its length increases, and after a particular time when the external load is removed, definitely it will come to the original position. This will not common for all the materials. Only few materials have the ability to regain its original shape or size. Those materials are called as elastic materials, and this property is called as elasticity. Okay. Now let us see the actual definition for elastic bodies. What are elastic bodies? A body which regains its original shape and size when the deforming force is removed is called an elastic body. Okay, sir. Now, what are plastic bodies? Suppose if the body which cannot regain its original shape and size when the deforming force is removed is called a plastic body, and that property possessed by the materials is called as plasticity. We can say some examples for plastic materials such as glass or some quartz-like material. They are the examples for plastic materials. Now let us see the important characteristics of the elastic bodies. That is nothing but the stress strain diagram. We know what is the definition for stress and what is the definition for strain. What is the definition for stress? Stress is nothing but the deforming force per area. Right? So what is the definition for strain? Strain is nothing but the change in dimension to original dimension. When we apply the external force, the length increases. Force means it may be load or pressure, whatever it may be. So that force will deform. That means it will change the actual shape or size of the material, so that it is called as the deforming force. So stress may be defined as the restoring force or the deforming force per area. So what is the unit for stress? It is Newton per meter square. How can we write Newton per meter square here? The unit for force is Newton and the area will be, the unit for area is meter square. Therefore, the unit for stress is Newton per meter square. And let us see the unit for strain. What is the formula for strain here? Unit for strain here, it is an unitless quantity. That means you see the formula here. Strain is nothing but the change in dimension to original dimension. So these two are the mere quantities. Suppose centimeter by centimeter or meter by meter. Those quantities will cancel each other. Therefore, we can say strain has no unit. Okay. Now, by using these two properties, the stress and strain, an engineer, particularly the civil engineer or mechanical engineer, he can identify the elastic property of various materials. It's a simple diagram used to find the elastic limit or yield point, finally breaking point of an elastic material. It will be helpful in many ways. Okay. Now let us see the importance of stress strain diagram. Now let us consider an elastic material. One end is fixed with a rigid support, and at the other end we have to add the load. So the load that may be considered as the stress. That should be the values of stress should be plotted along the y-axis. And when we apply the load, what is it, the length or dimension or diameter of the elastic material will be changed. That is nothing but a strain. The values of strain should be plotted along the x-axis as shown in the figure. Suppose let us consider an elastic material, whether it will be a metallic wire or a rubber material. A small quantity of load is applied, that is the stress. The value should be plotted here along the x-axis, y-axis, and due to the applied load, the length of the material will be slowly increases. That change in dimension or change in length, that value should be plotted along the x-axis as shown in the figure. Now, the curve, you see, this is the stress strain diagram for a particular elastic material. The starting point, that is an origin, that is nothing but O. From O, where the curve slowly increases steadily as shown in the figure. The curve is a straight line, it increases, not a straight line, anyway it increases with respect to the stress is increased with respect to the strain. Stress is directly proportional to strain. That means from the point O to the point A, the elastic material obeys Hooke's law. What is Hooke's law? Within the elastic limit, the stress is directly proportional to strain. This shows what? Up to the point, or from the point O to the point A, the material behaves as a perfect elastic material. That means up to this point A, the particular load is removed. That means we applied the load in the beginning. When the external load is removed, the material will regain its original shape or size or length. That's why we call this point OA is a Hooke's limit. That means the material obeys the Hooke's law. This shows the material behaves as a perfect elastic material. Okay, now we slowly increase the load again. That means in the beginning we applied a small quantity of load, for example 500 grams to the elastic material. Now we applied some more 50 grams to that initial load, so that the stress value slowly increased. In the same way, the strain also increased. That means when we apply the load, what happened? The length of the material, the length of the elastic material slowly increases. That increase in length should be plotted along the x-axis, so that the curve is slowly moving from A to A dash. A to A dash. So what is A dash? That means beyond A point or from A to A dash, that is the maximum elastic limit of the material. This means the material will regain its original shape, not exactly as same as the previous case. From the point O to A, the material will get the exact position, exact length, exact dimension. But here, from the point A to A dash, the material will come to the original position, but it cannot regain its original exact position or dimension. Therefore, it is the elastic limit. So, what is the meaning of this limit? Everything has a limit. So, from this word elastic limit, everyone can understand. Beyond this stress value or beyond this load, when we increase the load, the material will never come to the original position. That's why it is called as the elastic limit. So, beyond this value, everyone can easily understand that the material will lose its elastic property slowly. Okay. Now, on further increasing the load slowly. So, when we increase the load, the value of stress also increases. But here, you see the point B. The curve is moving from A dash to B. So, here, even though that means we add a small load here, the point B is reached. That point is called as the yield point. That means when the curve reaches the point from A dash to B, even though there is no increase in stress or increase in load, the strain increases rapidly. That's why you see there is no increase in stress, there's been load, but you see it's almost a straight line. That means the strain value is gradually increases. So that point is called as the yield point. Now what is the meaning of the load yield point? In this graph, even though there is no increase in load, that means stress, the strain value increases. So this point is called as the yield point. Now, further increasing the stress, that means the load, slowly the curve is moving as shown in the graph. The curve is moving faster than the previous case. That means we can understand that the material slowly damaged. It will slowly neck down. There will be some cracks in the elastic material, or we can say the outer parts will be slowly break down, starts to break down. That point is called as the tensile strength. Tensile strength means the material almost losing its elastic property. On further increasing the stress slightly, a small load is applied. Beyond this load or stress, what happens? The material suddenly breaks down. The material is suddenly broken as shown in the point D. So that this point D is called as the breaking point. So this is the end of the elastic material, end point. That means at the particular point D, the material is suddenly broken. So what is the importance of this strain diagram? This experiment will be repeated for various materials, copper wire or aluminum wire, iron wire, or some other elastic material. So when we change the materials, so that we can plot the values in the stress and stress diagram. From that, the engineer can easily identify what is the elastic limit of the particular material, what is the breaking point of the material, what is the limit of proportionality of the material. So by using this graph or stress strain diagram, the engineer will identify the elastic limit of the material so that he can judge, he can come to the conclusion that what will be the maximum load that can be withstood by a particular elastic material. So this diagram, stress strain diagram, is very useful for the mechanical engineers as well as the civil engineer or the construction of building material or machines, whatever made. Okay, thank you.